Greetings, Saintsmen. We're going to go get started here on lesson 6.1, which is perpendicular and angle bisectors. One of the first key terms that we're going to need to identify together is this notion of what equidistant means. And it's pretty straightforward. The word actually sounds a lot like what its definition is: equidistant or equal distance. So it is a point that is the same distance, or as I just said, equal distance. So this is what we mean by that. This dance, let's get that spelled correctly. Uh, it's this theorem that we're going to work on right now, which is the perpendicular bisector theorem. So, and again, let's actually talk about what the perpendicular bisector is. Um, we have here a line, right? And then we actually take and add some segments onto it. And what we're going to say here is that through this perpendicular bisector, a number of things are accomplished. So let's go ahead and name these points A and B. So um, when writing out the perpendicular bisector, and with one of the things that's going to happen is that as long as we have a point, let's go ahead and just accomplish this perpendicular bisector and do this dashed line. Okay, this being perpendicular. Remember, when we did the construction, it means that this point right here is the midpoint. So what we're going to say here is that we'll take a point on here, and let's just take this point right here, which is going to be the point C. And we're going to call this point, the midpoint, to be point P. And what we're saying here is that through a number of one thing's accomplished is that, for example, if this is going to be the case that this is the midpoint of the perpendicular bisector, is at any point, such as C, or even if I move to this point, and we'll call this guy C prime, right? A second C, not C subscript 1, C prime, means that C has been translated or moved along that perpendicular bisector. What we accomplish is that this point C is going to be equidistant to both B and A. And here's how we can prove that. Rather simply is that if, again, P being the midpoint, because there's a perpendicular bisector, it means that we have congruence between those segments. Now, take a look at what I can create here. If I connect C with both A and B, well, what type of triangle do I have here? But again, I have this right angle. Remember that if I have perpendiculars, I've created 4 right angles effectively, so that this is also a right angle, and we know that all right angles are congruent, so these angles are congruent. And then PC is going to be reflexively congruent to itself, so through side angle side, I could say that triangle APC is congruent to triangle BPC, because it's side angle side, which means that BC and AC, oh my goodness, struggling here. BC and AC will have to be congruent because of corresponding parts. So our theorem that we have here is this, is that a point on the perpendicular bisector is equidistant to either endpoints, the line segment. It bisects, all right? So we have a converse to examine here too. I'm going to try to do this a little bit more concisely than I did in my previous video. Okay, let's go ahead and just slide this guy up here. Again, I'm going to draw out my line segment here, and instead, what I'm going to do is I'm going to draw this not as a line, but a line segment. I'm going to take this line here, or this point here, and I'm going to take my endpoints to that point. All right. I hope to draw this in an equidistant fashion, but we'll mark it as what's going to make it congruent. So I have A, B, C with point P, right? And again, what it means is that because I have C drawn here, and these lines are perpendicular, and I'm given here the congruence that C, right, is equidistant to A and B. So in other words, if AC is congruent to BC and that's what's given to me, then what it means is P is the perpendicular bisector. So here's why is that again, if it'll wind up being right if I've given that this is perpendicular and just that those 2 points are congruent, I can then make further conclusions, right? Because look at what I have. I have this right angle, I have this reflexive side, and some of you guys are thinking, wait, Granados, it's ASS, angle side side, but it's not. It's not, right? This would be hypotenuse leg, right? So that exception that we have that makes this a side, side, side. So therefore, if that's the case, then that makes this guy have to be congruent to this guy. Okay. Let's do some problems from this section. Some of these you guys are gonna really like. And except for the last example we'll have today, it's a little bit more challenging. So, I have a line segment. I'm draw a line through it, and oops, my screen is rather sensitive. My hand is touching it. A, B, C, and D to make my C a little bit closer. All right. And given that A, B, and BC are congruent, and that this is a right angle, and it says that what's given is that BD is the perpendicular bisector. Okay. So, given AD is 27, the question for this problem is, what is CD equal to? Guess what is equal to? 27. It has to be, right? Because if this is a perpendicular bisector, it means that D, right, is going to be equidistant to both A and C, these endpoints right here on this line segment. Therefore, if AD is 27, this guy's got to be 27 as well. All right, moving on. Next. Let's draw a new diagram. All right. And here we are going to calculate, oops, I'm missing point S at the top. Okay. And we are going to find what PR is equal to. Well, here's what we're given. It's just this, that PS is 13 and SR is 13. Well, if PS is 13 and SR is 13 is what's given. Oops, I'm sorry, I put that in black. Let's go ahead and put that in blue. And then our work that we're concluding afterwards will be in blue. All right, so we got to figure out what PR is. Well, it means I got to figure out this entire segment. Well, what I know is if that these, right, are congruent, oops, as marked, it means that this guy's congruent to this guy, meaning this guy's got to be congruent to this guy because it's a perpendicular bisector, right? Has to be, because that leg shows that equidistance from S to P and S to R. So then, what's also given in the problem is that PQ is 5, so PR would have to be 10, okay? Because it would just have to be double whatever that other thing is. All right. New theorem here, which is this. It's going to be with the angle bisector, okay? Oops, let's go back to black. The angle bisector has the following. Great. Trying out my diagram. And this guy's all the convergence of all those lines right there. This is D, this is C. Got some more things going on here. Okay. And here is what we got. So we have an angle bisector here, right? That line, that ray AD is the angle bisector. So therefore, angle BAD is congruent to angle DAC. That's just the definition of the perpendicular bisector. So here is what we can actually conclude. One is that this line segment that was given here was perpendicular, okay? Because from B to D and B to C, that is my shortest distance, okay? Well, what happens is that because of that, I have an angle, and I have this reflexive side, meaning I have congruent triangles, which would make BD congruent to BC. Okay? So, if we have that, without the other information, the converse is going to be true. If BD is congruent to DC, then AD would have to be the perpendicular bisector. Or, sorry, is the angle bisector. Right? So, let's do another little example here. Oops. And then here we go. Showing that perpendicular relationship. A, B, C, and D. Okay. Copying these guys all down. And then here's some other dimensions. This guy's 10. This guy's 10. This is 56 degrees. Okay. For DBC. Okay. So what we need to calculate is what is the measure of angle ABC? Okay. So here's what we're going to come up with. Well, if this is going to be congruent, right here, right? 10 and 10 for AD and DC. And then it shows that this is the shortest distance. It means, right, through this perpendicular relationship, because the shortest distance, right, between a point and a line is going to be that perpendicular distance as we proved previously. So 56 degrees being this one, well, it means that these two guys are congruent, right? ABD and DBC. Therefore, ABC, the entire angle, would have to be twice that, 56 plus 56, which is going to be really just equal to 112 degrees. Straightforward. Okay, next. Grinding it out here. Lots to do. Let's do this one. It's going to be a little bit more like the one had the original example. Right angle, at K, L, say K, J, M, and L. And then I'm going to have my right angles, my congruent angles here. So this is clearly, KM is clearly a perpendicular bisector. And I'm just given that JM is 4x and LM is 2x plus 12. Okay, so what it wants me to solve is for JM. Okay, well, here's what we can set up. We can say that 4x is equal to 2x plus 12. Why? Because JM and ML would have to be congruent since KM is the perpendicular, is the angle bisector. I keep on just saying perpendicular. I'm just running a train with that right now. It's because we did the perpendicular bisector so frequently at the beginning of the lesson. So it's the angle bisector, right? This guy. So let's go ahead and now just complete. There's a little bit of algebra, right? So we're going to subtract 2x from both sides. 4x minus 2x is 2x. And that's going to be equal to 12. And I'm going to divide both sides by 2. So x is going to be equal to 12 divided by 2, which is 6. Now, that's not what it asked me for. It asked me for JM. Well, JM was equal to 4x. So I have to go take this 6 and plug it back into the value 4x. So 4 times 6. So JM is equal to 4 times 6, which is 24. All righty, friends, our last problem of the day, which is going to take several minutes here. It's kind of the most challenging one we have for the lesson, so I hope you guys buckle up here. Let me go ahead and write out what the example is. Oops. It's this. We're going to write an equation of the perpendicular bisector of the segment with endpoints. D is 5 comma negative 1, and E is negative 11 comma 3. Now, here's the thing. We'll start with that, but we're never going to graph anything. I'm going to graph now. With that said, I'm going to graph this just to give you guys some sense of what we're going to do and to show us our plan so we can deductively prove our answer. Because our answer is not just going to be, oh, I looked at it and this is what I think. But here's what we're looking to do, right? So let's go take a look at this in the coordinate plane. So we'll graph these guys. We have y, we have x. Okay, we have point D, which is 1, 2, 3, 4, 5, negative 1. Okay, E, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, up 3. And this is E. I'm going to go ahead and take this and I'm going to like connect the dots here, right? So I have this line. Now it wants an equation for this, the perpendicular bisector, which is going to be like somewhere around here, right? In theory. And then it's going to be perpendicular to this line. So what I need to do, and again, we see perpendicular, oh goodness gracious. There we go. We see it's a perpendicular bisector. Well, two things should come out, right? This is going to be the midpoint. Okay, so we're going to have to calculate there. And then if it's perpendicular, we're going to have to calculate slope. All right, so we need an equation for a line that's going to be this line. It's going to be like y equals mx plus b. Okay, we have a point to slope, and we're going to use point slope. We could use slope intercept. It doesn't really matter, but y equals mx plus b is slope intercept. We need that equation for this blue line as it relates to the black line DE. So we're going to use a point, the midpoint, to get that, and then we're going to use DE slope, and then find that perpendicular slope, which you guys know is going to be that negative reciprocal. So let's go ahead and erase all this stuff because we don't need it. Okay, this is all nice and great. But what we really need to find is the midpoint to DE, right? Because we need that to extract that out of this. So we have x1, y1, x sub 2, y sub 2, okay? And we're going to take the sum of my x's, 5 and negative 11, and divide by 2, comma, the sum of my y's, which is negative 1 plus 3, we're going to divide by 2, okay? 5 plus negative 11 is negative 6, right? 5 minus 11 divided by 2. And then negative 1 plus 3 is 2 over 2. So this is going to be a negative 3 comma 1. So I have now my midpoint. Now the other thing I talked about is I need to take my slope. I've got a point, and I'm going to need to get a slope. So we'll take the slope using the slope formula for DE. Okay. And it's this, right? The slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which is going to be 3 minus minus 1 over negative 11 minus 5, right? So it's going to be 4 over a negative 16, which is negative 1/4 when I simplify. So that is my slope, okay? Now, that's the slope of DE, but I don't want the slope of DE. I want this perpendicular slope, right? So the perpendicular to DE is going to be the negative reciprocal, which is going to be just a positive 4, all right? And now I can find the equation for this using point slope. Now let's use point slope. I could use, and I'll do this just for fun with y equals mx plus b as well. But point slope is y minus that one y sub 1, which is the 1 point I got over here, right? And then it's going to be the slope times x minus x sub 1. So in other words, I'm going to take y minus 1, right? Because that's my y. is equal to 4 times x minus 3 or plus 3. So I have y minus 1 is equal to, and I'm going to distribute here, 4x plus 12. I'm going to add 1 to both sides. So I have y is equal to 4x plus 13. Goodness, this wind up screen is really struggling here. Now, could I have done this a different way? Of course, right? With that point, that slope, we could have actually done the slope intercept. Again, right, where we have y is equal to mx plus b. Well, we'd have to solve for what b is, and we have y, which is, right, is this whole thing with 3 negative, or negative 3, 1. So I'm going to say 1 is equal to my slope, 4 times negative 3 plus b. So 1 is equal to negative 12 plus b. And then I add 12 to both sides, right? So then I have, this is going to be 13 is b. And then I'm going to plug that thing back in here. I already have my slope of 4, plug in here. So I have y is equal to 4x plus 13. Same exact thing, okay? Doesn't really matter which way we do it. I'm pragmatic. I just want to get the right answer, all right? So see me, guys. Got a lot of work to do. If you have any questions, and let's get after it in class.